Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at geometric sequences. So let's go ahead and get started. So imagine that I have the following table here. And so I have the following values here. So I have my A sub n like here, and it's going to just be 1, 2, 3, 4, 5, like so. And then now notice what happens in the output. I'm not going to tell you the actual general term just yet, but here's what's going on. I put in the 1, if you will, and I just start with the 2, excuse me. And then from the 2, I go to a 4, then from 3 to 8, and then from, so that's kind of funny looking. 4, 8, 16, 32. Now so far, at least in the video series on this channel, we're familiar with arithmetic sequences, but this is not arithmetic because the distance, or the d if you will, the distance between the values, it changes each time. So the first time is plus 2, then it's plus 4, then it's plus 8, then it's plus 16. Because the value that you add to the pre-existing term changes, we know this is not arithmetic. So we need to figure out, okay, well, what's going on here? We start with the 2, then we go to a 4, then an 8, then a 16, and a 32. Well, we can clearly see that the values are doubling. And this is kind of where it meets up with an ideal of a geometric sequence. And a geometric sequence is when you have consecutive integers, when the ratio between consecutive terms, is always the same. So every single time here, we are doubling the actual output term here, if you will. And so that's why essentially the ratio, or the R here, is going to equal 2. Now when we say ratio, we're talking about the relationship between two numbers. So in other words, when to go from 2 to 4, you have to double it, 2 over 1 if you will, as a ratio. To get from 4 to 8, you have to double. To get from 8 to 16, you have to double. So this ideal of doubling over and over and over again, that is what is consistent between the terms. And so if we wanted to actually write out, what the actual formula would be 2 to the n power. So, so 2 to the second power is, 4, 3, or 2 to the third power. So every single time we get that. So actually, yeah, so 2 to the first power would be 2, 2 to the second power would be 4, 2 to the third power would be 8, etc., etc. You can see that. And so this is kind of what's happening here. Now, having said that, I want to expose you to the formula we use to find the general term of the sequence. And it's kind of as follows. Let me rewrite this. So I got 1, 2, 3, 4, 5. I'm just trying to get this over. 2, 4, 8, 16, 32. So that's my table. All right, now the general term of the sequence is as follows. A sub n equals A sub 1 times R, so put a nice dot here, R raised to the n minus 1 power. So let's see if we can make this nice and simple. We're going to take here A sub 2. We're going to do an example here. So A sub 2, this is our formula, A sub 1 times R, or the ratio to n to the first power. And we want to figure out as follows. So I'm going to plug this in. A sub 2 is going to equal A sub 1 times, we're going to have our R here to the n minus 1. So let's plug in our numbers. So we know that A sub 2 is going to be 4. So that's going to be 4. A sub 1 is 2. We know that our R is 2. And so then we're going to raise it to the 2 minus 1 power, like so. And so this should be very clear. 2 to the minus 1, that's just going to be the same as 1. And so 2 to the first power is 2. And so you can clearly get 4 equals 4. That's how you're able to find any term that you want. Let's do one more example. Now in this particular table, we're kind of doing the opposite of what we did last time. So in this table, this is what we're going to have. We're going to have our 1, 2, 3, 4, 5 again. 1, 2, 3, 4, 5, like so. And then we're going to go down like this. 32, 16, 8, 4, and 2. So you can clearly see that our R here is that basically we're going down by, by half. That's kind of what's happening here. So it's going to be our R equals 1/2. And so if we want to find the general term for this one, this is kind of how it will look like. So this time we're going to do a sub 3. So we're going to do a sub 3 equals a sub 1 times r to the n minus 1. So let me put a little time sign here. There we go. So a sub 3 is going to be 8. Let me change the color for you. 8 equals a sub 1 was 32 times, we got 1/2 raised to the 3 minus 1. Or you could just say raised to the second power. Make it a little bit easier. Raised to the second power here. Just cross that off, second power. So I get 8 equals 32 times 1 over 4. And then we get 8 equals 8. Nice and simple. Not that complicated. But another way of looking at numbers and understanding what's happening in terms of a sequence. So let me go back and recap what we did and conclude this video. So in this video we took a look at geometric sequences. A geometric sequence is not when you add terms together, but the distance between terms are the same in terms of addition, but rather that the ratio, in other words, the distance in terms of multiplication is the same. And so in this first example, our ratio was 2. In other words, the distance between these was always times 2. You doubled it, you doubled it, you doubled it. And when you understand the sequence, you can find the general term of the sequence. In other words, you can find any term that you want by just understanding various values. And so the generic formula for this is a sub n equals a sub 1 times r to the n minus 1, with r being the ratio. And you just plug in everything appropriately and you get the answer. And so in this last example right here, the only difference was that the ratio was 1/2. In other words, every single time the term went down by 1/2. That's what was happening. And then we did the general term of the sequence again, and we were able to calculate it and confirm it because we know this is correct because it's in the table. That's why I picked that particular value. So I hope that this video made sense and you were able to follow along and understand what we were talking about here. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.